Now, what is the path difference of the rays reaching a 2 lambda? So what is asking the intensity equal to intensity at 2. Find the final distance x such that intensity at point P is equal to intensity at 2. So next what we get should be the maximum. No? Yeah. So here if it is 2 lambda, here what we get? Next maximum will come lambda, and the next maximum will be somewhere infinity. So better I think rather than fighting with this. So have first a background. Whenever you get a questions of these kind, these are the two sources that are given. Select a S1 and S2. What is the path difference? What is the distance between 2 lambda? What is the path difference of the rays arriving here? 2 lambda. The next maxima will have a path difference of what? Lambda. Then what happen? It will become maxima. Then what about the other one? The next maximum will be there at infinity. And there, what is the path difference of the waves arriving there? Shall we put like this 0? How 2 lambda there? Should be 0 there. The path difference will become 0. Able to make it out methods, and 1 lambda will come here. So this is a maximum. Other maxima will come. So what is the path difference of the rays now arriving? It should be the lambda. Then only what one will get another intensity. No, you make a triangle here now. So you have a triangle. So construct a triangle now. And get that, and it will make an angle theta. This will be theta, and this is what? Delta x. So this is x. This is almost equal to dm. So this is the second maxima. Here will be the first maxima. So what is again? This is 2 lambda, no? So cos theta equal to delta x by 2 lambda. This will be the thing. So delta x is equal to how much? Lambda. This is 2 lambda. So we'll get theta equal to 60 degrees. So once you know theta is 60 degrees, then you can come for tan theta equal to x by d. Tan 60 root 3. Fine. Now, instead of the point P, instead of maxima, if it is minima, tell me what you are going to do. What changes you are going to make. The point P, if it is a minima, then after 2 lambda, what do we get? We get here 3 lambda by 2, no? Minima will be here, 3 lambda by 2, then lambda by 2. Please do analyze. Just you can't depend on mathematics. Okay, this will be 3 lambda by 2, this lambda by 2. Fine. So this will be, if it says in the problem, let's assume that if there's a minima, then in that case, what will happen? You should write equation cos theta equal to delta x, where the delta x will become, so like if the first this minima is there, 3 lambda by 2, you are going to write. I'm finished. Sure. So I can ask you what happened, the position of the first, like a minima or maxima here. The idea is same. Instead the point P is here, then delta x, what you are going to write? 3 lambda by 2 here. Then you are going to calculate that position. Okay, so it's like instead of doing 5-6 problems, no, just do analyze. I think in Hycon we have a problem where he is asking the position of minima. So that doesn't, just delta x you to replace. Okay, now instead of 2 lambda, if I write here, select a 5 lambda by 2, what changes you are going to make? Now we don't have any question based on this. Let me just share an idea. I need bigger diagram. No, there are two sources are there. The path difference between them, let me make 5 lambda by 2. Tell me what will be your conditions now. Here it will be 5 lambda by 2. Next what we get, and this will be at infinity, path difference will be 0. After 5 lambda by 2, what you get? You get 2 lambda, then 3 lambda by 2, then lambda by 2. It can happen. So they can test you with a question like this also. This will be 2 lambda, 3 lambda by 2, lambda, lambda by 2, and this will be 0. This occurs at infinity, path difference. So all maximas I'll indicate by red color. Minimas by green color. Because we do have discussion of what, like always maximus like a 5 lambda by 2. It can happen like this also. Can be asked here. You just be careful. Okay, we'll take the next one. Now after this, what all other very important thing is like a Lloyd's mirror. Then two signals are there, or like a two sources are there. And if I move around a circle, these are the very fundamental problems can be asked in advance. I'm talking about final advance. It may look very simple for you, but definitely they'll ask you the best of best questions, even in that also. With two sources, if you go around circle, bigger circle, smaller circle. I think I discussed all other cases. Please do revise. Okay, now let me do the Lloyd's mirror. Let me keep a source at certain height. And this will be the screen. So basically Lloyd's mirror. Why do we prefer Lloyd's mirror? To measure the wavelength. To measure the wavelength of the light, this particular Lloyd's mirror is used. So first we'll take one ray. Those who know already this, you can prepare some other numericals. Huh? If you're already aware of this concept, you work out some other numericals. This is a ray 1. So this is a ray 2. And I'll adjust the diagram. This is screen. Okay, let's come for now. So this is the see that they are not parallel. Huh? These two rays are not parallel. There's only condition which you have to follow it. So the ray here again a direct ray. Again a direct ray from here will come. So this is a ray 1. This is a ray 2. So how the interference I am going to compare between the direct ray and the reflected ray. Direct ray and the reflected ray. So there's a direct ray. And there's a reflected ray. Even there's also a direct ray. And this is a reflected ray. Okay, fine now. So what is the expression for position of maximus minimus? So where do we see that maximum minimus? The maximum minimus we'll see in this region. So this is screen. So here we can see like why we'll see only in this region, because in that region only what happen, the interference of the rays will occur. So you don't get the pattern everywhere on the screen. Only in this region the interference pattern will be present. Any theoretical questions can also be asked. Just be careful. Now let's get into this one. So what are the some assumptions of the distance between from source to the screen? This is screen. This is a height. Okay, this you can write d naught. It will form an image at what distance? At a distance d only. So if I extend this ray, okay, then not needed. Just will show this one. So this will be d naught. This will be f dash. That s dash what happen will become coherent sources. So this is a source of wavelength lambda. Due to reflection, wavelength will change. No, we know wave property. If a wave gets reflected by denser or rarer medium, wavelength will not change. Whatever the lambda will be changed. But what happens? There'll be a phase angle will be there. They'll encounter a phase angle of pi radian. If you look at this ray, it will have zero phase. After here, it will have zero phase. Of course, it will cover a path. But due to reflection, it will encounter a phase angle of a pi radian. So additional path lambda by 2 is what we have to introduce in the calculations. So this is similar to like a YDAC, no? This is similar to like a YDAC, the distance between the slates D, this is capital D. Only we have to write expression for the path difference. So where is the path difference now? How to take the path difference? So again, if you take the path difference, we have to extend the path difference I have to draw this down. Yeah. It need not be some rough diagram. Okay, this is the angle 90 degrees, so call M. So there's a path difference between these two rays. Okay, call this is theta. So what is the path difference now? SM. So we'll give the name. Same symbols I'm using. What we earlier did, the same symbol. So they'll be easy for you to recollect. What are the rays it will cover? It will cover the distance SM1, M1P. Path difference, I'll write equation. This will be equal to SM2 plus M2P2, then lambda by 2. Why lambda by 2? We should take because it will undergo phase change of pi radian. So here what happens if the ray comes with a phase angle like this? After reflection, so phase angle of pi should be introduced. This is minus of sp2. I'm comparing these two rays, one direct ray and another is the reflected ray. For these two rays is what we are discussing the concept. So look at the mathematics. This will be Sm Sm2. We can Sm1 Sm2 is equal to S dash M2 M2 P2, and this will be plus lambda 2 and sp2. So this will become any equations can be right here. So similar to this is YDS, so this everything should become equal to S dash it's like a S, yeah, S dash M2 P2 minus sp2. So that this, let's rearrange this one. So what is this F dash M2 MP2? So this will become everything like a F dash P2 minus sp2. This should be equal to delta X. Okay, this is some delta X dash, I'll write it. So this should become equal to d sine theta. Then for n lambda, this will become d tan theta. Tan theta will be y max by capital D. So if you solve this, so y max will become, I'll write directly, will be lambda capital D by small d. It a reverse, no? Reverse of that we are getting. This is for maxima. For maxima, what happened? We'll get this condition here. So I think definitely they'll trouble you a lot in exams. So don't just directly jump into formula like what we had in ordinary YDS. For Lloyd's mirror, the condition for maxima will be the reverse. That of the minimas will come. So you should start with n equal to not 0, n equal to 1, 2, 3, 4, 5 like this. So the value of n will be 1, 2, 3, 4, 5. So you can locate the position of the maximas here. Is it all maximas are available here? So if you look at this region, no? So the light itself will not reach here, no? The light itself will not reach. So the number of maximas are visible is only this region. So for that, what happen? We should calculate P1, P2, this particular length. Then we know fringe width. From fringe width, what will happen? We should calculate how many fringes are visible. So is it all fringes are visible? The answer is no. So some will be here, what happen? No light will enter, no refraction will take place. So no interference will occur here. Superposition will not occur here. Better don't say no light will reach. Here what happen? This is out of view, no? Or it is out of field of view. Only in the field of view, what happen? The interference pattern will be visible. So they'll ask you how many like a fringes are visible. So for that, you should calculate mathematically P1, P2, and you know fringe width. Now what is small d? Small d, we assumed it to be equal to 2d naught. So here you write it. Then here also, what is the fringe width? The fringe width will be lambda capital D by small d. Then if you know P1, P2, the number of fringes visible, we can find out here. So the number of fringes visible will be P1, P2 by the fringe width. So as you move this screen towards left, then when the screen, I'm taking point O, when the point O comes and touches the M2, then we see here a minima. This condition is something very, very important, can be asked in exam. I'll draw the diagram. No, the screen is dot and here is a mirror. There's a source. Okay, now what we see is we see a minima here. Do we see any pattern below this line, this axis? Or only above that will be? At the axis, we'll get a minima. Oh, so sorry, this should be, I should move, no? Yeah. No, few clarifications, we have to do it. So what we get is, there's a minima. Now look at this. This is a D naught, there's a mirror. And now, do we get any pattern here? No. What all the pattern will be visible in this region? Sir, why can't light? Of course, light will come here. So the light what happen after getting reflected, no? So we can see in this region. So here there won't be any interference pattern. So if you put like this, here there won't be any interference pattern. Opaque, no? The light itself blocked. So in lab, what we see complete dark. This everything. Because let's think about, we are doing this problem in the dark room. Doesn't mean that here destructive influence. Here no light will enter. In this region, no superposition of rays here. So this will be completely dark, absence of light. Not due to destructive interference here. No light reaches here. Then afterwards, what happen here, we'll get a complete illumination. And there's only one source. So don't think that again we'll get a pattern. So they'll trouble you questions like this. Huh? So if you draw a line, I think I'll go to the next page so that we have. Where there's a totally lab-based question. So can be targeted for you in exams because as such, we don't do labs, no? So definitely IT process may target you with these questions. I'll put the diagram in order. Okay, this is the D node. So if you draw a line, oh, yeah, see no. So we'll like this. I can. What about here? So this part, no light, and it will be complete dark. Afterwards, what happen here? So here light will reach. Light reaches almost uniform illumination. No interference pattern. And here what happened, we'll get interference pattern. Interference pattern what happened, how much in a certain specific region here. There's a basic Lloyd's mirror, it happens. So here now we can put it. Again, uniform illumination. No light, complete dark. Got the idea, no? So this is what the basic Lloyd's mirror, when you do in the lab, no, you can notice, provided the room should be completely dark. Then we do notice of this kind. Any good conceptual theoretical questions can be asked, you have to be careful. Okay, I'll close the class. I have some work, some problem is there. Okay, we'll do one thing. I'll upload the assignment. The same assignment what some matchings are not there and single options are not there. I'll upload that. Try to work out some good numericals in that one. Tomorrow I'll start the screw gauge 1 year caliper. I'll come back to YDAC, some good numericals on Friday. The last numericals, advanced level 1. Meanwhile, you have to revise all the things. The first June session we have given